Um, hello, grade 12 learners and teachers in physical sciences. Another session again of in electrochemistry. Remember, electrochemistry is where we find the galvanic cell and electrolytic cell. So let's find out the latest questions with regard to this section. Now there was question number 8 in one of the question paper recently, which says to say the cell notation below represent an electrochemical cell. A voltmeter is connected over the electrodes of the cell at standard conditions. Fine, no problem. Let's look at that cell notation. We know that Q will be the salt bridge. On the left hand side of the salt bridge will be your oxidation half cell, and then on the right hand side is your reduction half cell. Therefore, on the right hand side we don't have any electrode, that's why we use platinum. So no problem. Then the oxidation half cell then involves the electrode that is X, which is not known. Now during the reaction it was observed that 4.8 grams of electrode X is used to lose 2.408 by 10 to exponent these electrons. Remember that number of electrons will give us obviously the number of moles of electrons. Fine. Define reduction in terms of oxidation numbers. Very important. It reminds us of grade 10. Reduction in terms of oxidation numbers will be now decrease in oxidation numbers. So decrease in oxidation number becomes the reduction. Next question, 8.2.1. Let's see what's happening here. There's a write down number 1. Energy conversion taking place in the cell. We know in a galvanic cell, therefore chemical energy is converted to electrical energy. You just write chemical to electrical. There's no need to repeat the energy part. Fine, no problem. 8.2.2. Then they are saying to us now, write down 2 functions of the component Q. That is, component Q is said is a salt bridge. Therefore, write down 2 functions of the salt bridge, then which will become simple complete the circuit. Every learner knows that one. Complete the circuit. And then number 2, very intelligent, will be to maintain electrical neutrality. Very important. Fine, let's go to 8.2.3. now what do they say in this one? They say write down the reduction half reaction taking place. We know that which side of this one we say is the side where now chlorine gas is changes to chlorine ions is the reduction half cell. So therefore you go to the table and then just copy the forward reaction, which will mean that now Cl2 plus 2 electrons forms 2Cl2. That is our reduction half reaction. You get 2 marks for doing that. Now in 8.3 they are telling us now to say calculate the relative atomic mass of the anode. Remember, the anode now is the X part. So find the relative atomic mass of the anode. Obviously, the second question they will say now we have to, in other ways, we have to identify what is that one. So fine, let's go. We start with our in that one, the relative atomic mass. The anode, remember, it will be this reaction. It will involve this reaction where X produces X2 plus 2 electrons. I think you can see from the cell notation that 2 electrons are lost there. Fine, let's go to, we are given the number of electrons. So we can find the number of moles. Number of mole of electrons will be the same as the Avogadro's number. This one, the number of particles divided by the Avogadro's number, which will give us, according to this one, is 2,408 by 10 to exponent 23 divided by 6.02 by 10 to exponent 23. Therefore, the answer here will give us 0,4 mole. That is the number of mole of electrons. But in this case now, we look at this reaction. Number of mole of electron, can you see now, is to the number of mole of X. They are in the ratio 1:2. Therefore, number of mole of X will be now half of the number of mole of electrons, which will be half of 0,4. Then this will give us 0,2 mole. Fine. Now we have got 0,2. We can calculate the molar mass now. So the number of mole of this one, which loses, according to this one, they gave us that it loses 4.8 grams. You look at the statement, yes, it loses that one. So now number of mole will be now of X. A number of mole of X will be given mass over the molar mass. The number of mole is 0,2 equals to given mass over, given mass is given is 4.8 divided by M. Therefore, the capital letter M will give us, in this case, which is that of X, isn't it? It will be the same as now 24 grams per mole. Fine. You go to the table and find which one is 24. We can see that now if it's 24, therefore M is magnesium. So, but we're not told to identify. Then we just leave it up to here. No problem. That was the question there now, where we have to calculate the relative atomic mass or molecular relative formula mass in this case. No problem. Let's go to the next one. 8.3.2. They say calculate the initial reading on the voltmeter. In this case, connected to the electrochemical cell. Now we have to find the EMF. So already we know that M is magnesium. Therefore, we can calculate the EMF. EMF, that is 8.3.2. So EMF of the cell will be now the electrode potential of the cathode, and then minus the electrode potential of the anode. Then this will be, in this case, the cathode is 1.36, anode, it's a magnesium negative 2.36. Therefore, the answer will give us positive 3.72 volts. Very important.